All right. Thank you for coming to our next session. And this one is called FDO Vouchers and Authentication. And I'd like to welcome Bill Leddy, who's VP of Authentication and Identity at LoginID. Thank you, Bill.
Thank you. Okay, so problems. Critical infrastructure. We have a lot of exposed critical infrastructure that is subject to attack, and IoT devices can be a source of those attacks pretty easily. Probably everybody's relatively familiar, or at least remembers the Mirai botnet attack. You know, admin for account and password, not a good security policy. These weak, low-end IoT devices were used to create an attack. And this attack was basically launched by college kids. They weren't even really trying to be all that bad. It wasn't very stealthy. It was not terribly targeted. And it wasn't even a state actor. So start thinking about what a state actor could do. This could lead to, you know, biblical apocalyptic proportions, you know, living dead walking the earth, cats and dogs living together, you know, all that sort of thing that's been previously mentioned, maybe even in movies. So now that may sound like fear porn. Okay, maybe a little bit, but not really that much, okay? Because in addition to the Mirai botnet attack, there were state-sponsored attacks, including power outages in the Ukraine grid, the Stuxnet attack. Then there were some financially motivated hackers that, like the Continental Pipeline, the meat packers, and other things like WannaCry. You know, if you imagine that, you know, as long as you're dealing with attackers that are financially motivated or they're state actors that can be subject to responding attacks, then okay, maybe they're rational. But if you have somebody that's just a total terrorist and wants to take the whole thing down, you're kind of living in a different world. So if you look at the Presidential Policy Directive on the right side, you'll see all these critical infrastructure things. And think about all the devices that are connected to those systems, and you know, how many of those do you think are secure? And we probably all would have pretty much the same guess. So there is a federal program called FedRAMP, which is basically looking at what it means to securely connect a device to federal government, federal systems in the US. There's similar things elsewhere in the world. But basically, how are we going to secure this infrastructure? And the government is part of this solution because they have a lot of the infrastructure and the regulation to make this stuff happen. So problem number two, and this was alluded to slightly in the previous talk, on the consumer side, some of these devices are so complex, only an 8-year-old child can figure it out, and anybody over 30 hasn't got a chance, right? In the commercial space, you know, think about all the lights just on the floor of this building. If these were all smart light bulbs, how do you get them to all be configured to be the same? How do you get them all attached to the same system? How do you make that kind of onboarding easy so that they can easily be managed? And then in industrial, you know, think about refineries down along the Gulf Coast and all the remotely operated valves that are in those systems, and the difficulty in installing them, maintaining them, and securing them. And then think about all the movement towards manufacturing, robotics, and everything else. How do we make this stuff secure going forward? So, and when I say onboarding, not just make it secure, but make it easy to put on board. I think previous speakers had a slide talking about the cost of these things. You know, the cost of the installation of a lot of these things and maintenance is far more than the actual cost of the device itself, particularly on the low-end side of these devices. And then trusted supply chain, right? We're hearing more and more about this across a lot of different industries, but you know, you may have something that's being built in a factory in a country that you know, could be friends this week and maybe not so friendly next week, and maybe should not be fully trusted. And that device that gets manufactured is going to go through multiple levels of distribution, be in a warehouse, and ultimately end up with a retailer who sells it to an owner, and then the owner is going to want to connect that to an IoT management system. So through the supply chain, who can you trust? And maybe you shouldn't trust anybody too very much. So FDO, FIDO device onboarding, which was kind of explained by Gary and David in the previous talk. But basically what happens is when a device is initialized at the factory, essentially think of it as a private key is stuffed in the device, and a secure device, the FDO client is stuck in the device also. So you've got somebody you can talk to, and it has the ability to prove that it is who it says it is. Then it goes through the supply chain and ultimately ends up in some user's hand. Here I say consumer, it could just as easily be commercial, industrial kind of setting. Once the device wakes up, it goes to the rendezvous service, which I just kind of view as a dating service, or goes and asks, who's my mother? And basically, how should I get configured? And when it gets that information back, it goes and talks to the onboarding service that's assigned to it to configure the device. And as part of this process, there could be a wide variety of different onboarding services, and there'll probably be a variety of different rendezvous services. And those rendezvous services will be configured into the device at the same time that the FIDO device onboarding stuff is put in at the factory, so it knows where to go look for endpoints that can be used for the rendezvous lookup. The thing that's interesting, if you look into the FDO spec, is vouchers, which are an important part of this, are pretty much not addressed in the FDO spec, and it's kind of intentional. It's a hard part of the problem, and the scope that the FDO working group, or the IoT working group, bit off to begin with is pretty substantial. But I think the fact that it's not in the FDO spec makes it actually a pretty interesting opportunity for all of us to think about. So one of the interesting things that the FDO spec has is something called service info, and this basically allows custom services to be installed. So at the same time you're installing that FDO client at the factory and essentially a private key at the factory, you can also put in some custom services. And those services are installed at the factory, but it allows for updates later. So if you have a smart client sitting out on the FDO device, you now have a secure channel that you can talk to it. So the onboarding service, can, when it wakes up, there's a couple things that'll happen. First, it'll say, oh, who's my owner? Here's my preferred, the owner's preferred color is this, preferred temperature is that, time zone is this, and do some personal configuration for that owner. But the onboarding service could also start populating that device with personality. So at the factory, you can build a very generic device, not know who it's going to, but when the owner takes control of that device, then it talks to the right onboarding service and starts personalizing it for that owner or for the applications that owner is most interested in. And this is really pretty powerful once you start understanding what this does. You can have a really dumb device at the factory, and you can make it a lot smarter when it actually the owner takes control of it. So you don't have to necessarily trust to have all your software you don't have to have a complex software system installed at the factory. It can be pretty stupid at the factory and get a lot smarter later because you have the secure path to talk to the thing. So to me, IoT is actually an interesting identity problem. So, we've all sat in offices under light fixtures, and imagine that light fixture was installed by a contractor in a building that's rented by your employer, and that building is maintained by a management company. You and your coworkers are sitting at that light fixture. Who gets to control that light fixture? Is it some guy, 6 states away, or should you, from your smartphone, be able to control that? And based on your attributes tied to your identity, the attributes of that IoT device, we should be able to allow people sitting near the light fixture to select what they want to do. And this is where identity and IoT coming together get really interesting. There's a lot of interesting use cases we look at going forward as IoT gets more broadly deployed. So today we have FIDO Authentication, and we have FDO, which is just coming to life now, and OpenID. These three things together make for a pretty powerful opportunity to combine identity, IoT, and be able to manipulate the ownership of IoT devices, starting with FDO, because you have this initial hook into the device at the factory, and then through its life cycle until it arrives at the user. We can build some pretty powerful things with this. And the FIDO Alliance is responsible for 2 out of 3 of these, and then OpenID and decentralized ID are being worked at in other arenas. So voucher management. So imagine that when vouchers initially get created and the device is manufactured, that voucher, let's say, is created at a voucher management system and installed at the factory, and each time it moves through the supply chain, there is an individual associated with an organization who swipes a finger, smiles for the camera, whatever, but uses FIDO authentication to propagate the movement of these IoT devices through the supply chain. And this allows traceability to say where that thing's been and how it's been moved along from one spot in the supply chain to the next as you go through the multiple levels of the supply chain. And basically use identity and strong authentication to help secure the supply chain as these things move through. And then at the end of the supply chain, you have an owner, and the owner, again based on identity, could say have a preferred IoT management console and automatically hook up the user's device into their preferred IoT management console and do that quite seamlessly, right? You know who the owner is, you know what the preferred IoT console is. There's not 500 IoT consoles, just make it really smooth for that to just show up for the consumer. So you can make this very smooth for the consumer experience as well as industrial and commercial settings. So we've got a little demo, and what you'll see in this demo, it's pretty short and goes pretty quick, but you'll see a power regulator that's an IoT device that's running the FDO protocol, and what it'll first do is it powers on, and then it will reach out to the rendezvous service, and the rendezvous service will then tell it where its onboarding service is, and then the onboarding service will basically populate that device with what it needs to know, and then the device comes online and shows up in an IoT console. So could we run the demo, please?
In this demonstration, we'll present usability of FIDO device onboarding standard in industrial, enterprise, and consumer scenarios. On the left, we can see a standard European DIN rail breaker board with 3 main breakers, one for each electric phase, and 3 smaller 16M breakers for separate lines. Right next to them, we have 2 LoginID developed 110 to 240 volts mains voltage meters that are FDO enabled. The first meter has already been onboarded via FDO and is now enrolled to LoginID AWS Management Console. We can see on the right side in our things there is a device, and if we go to our MQTT test client, we can see the device is sending a voltage readings to our topic. We're now turning on our second device. We can see that it's loading, the meter is fresh new out of factory. It has only address of rendezvous service, FDO credential, and special Wi-Fi configuration. It does not have any AWS configuration, any other kind of information. It will receive all of that by onboarding via FDO. If we look in the top left, we can see the device have successfully connected to the pre-configured rendezvous service and have received the address of the device onboarding service. If we look in the central left, we can see that it has successfully onboarded via device onboarding service. The onboarding service on the fly via its broker was able to generate fresh AWS IoT credentials and inject them using the service info extension profile. If we now turn our attention to the right, we can see the device was able to successfully connect to the AWS MQTT server and is now sending voltage reading to the specified through the service info extension topic. If we look at the things dashboard, we can see that another device was added. What this demonstrates is that FDO is able to fulfill 3 important criteria: control, ease of configuration, and agile resource management. Control is the ability to take over the device by having cryptographic proof of device ownership, a voucher. No voucher, no device. The second is ease of configuration. The device can literally be configured by turning it on. This is really important for larger industrial and commercial deployments. Most of the IoT attacks today are based on simple credential stuffing and reuse. This issue is unavoidable so long that each IoT device must be configured manually. Lastly is agile resource management. Instead of having pre-allocated infrastructure pre-injected sensitive information that is costly and dangerous, you can simply set up necessary resources on the fly. More cameras, more licenses, more servers, vice versa. The off-hands nature of the FI device onboarding means that we can connect devices on the fly to our management consoles and have no-touch setups, which is really important in consumer enterprise scenarios, like in this home assistant demo where our voltage meters have been automatically added, which enables us to view graph visualization of our readings.
So what we saw there was a IoT device with an FDO client on board, power up, go find the rendezvous service. The rendezvous service told it where the onboarding service was. The onboarding service then configured the IoT device. The IoT device started doing its thing, and there's a little bit more work in here in hooking it into the AWS IoT console, but basically it was populated into the IoT console and ready to use. And so the point here is that FDO works. It's live today. And I'll talk a little bit more about our rendezvous service that anybody can use in just a minute. But so anyway, FDO really works. There's a real-world example, and this was done using our code, not the open source stuff. So looking at IoT forward, what does the future look like? I think there's some very interesting things, particularly when you connect IoT to identity. So one use case I like to talk about is, can I use my smartwatch to buy gumballs from your IoT device? And it's kind of interesting. You could either provision payment tokens into these devices individually, or if they're tightly coupled with identity, you could actually have the transaction occur in the cloud, where my wallet's in the cloud, your wallet's in the cloud, and we do the transaction in the cloud without the transfer of tokens. So there's some pretty interesting things around payments going forward for IoT devices. So, and IoT ownership is something that I've been interested in. So if I lose my laptop, if I lose or something, or somebody claims ownership of something, I can prove that I have the ownership of that device because I've attached it to my identity, and I have it. And if I ever want to transfer that, whether I want to give something to my kids or want to sell my car or whatever, I can now transfer that ownership from my identity to somebody else's identity. And this is the interesting part, where if we can tie together FIDO authentication, FDO, and identities, there's a pretty interesting world out there looking forward. And there's some fun stuff waiting for us as we build this stuff out. So what's the benefit of this? Well, first we get to secure the ecosystem, the critical infrastructure, which is pretty well needed. We can create much better consumer experiences, both not just for the consumer, but also for commercial and industrial IoT management. And we can help align across identity, authentication, and all the other standards that are coming along. So call to action, get involved. It's kind of what Gary said at the end of his talk. There's a lot more work to do here. The FIDO Alliance IoT Working Group has been doing a great job. There's a lot more things to layer on top of this. A good place to start is the FDO spec. The FDO spec is available online, free, no charge. Go get it. Have some fun reading. Join the FDO Working Group. And we have stood up FDO.cloud as a rendezvous server, and it's pretty much our commitment to keep that up. Anybody can use free. So anybody can come and say, hook up their onboarding service, register their onboarding service into what we've done. So, but we just want to make this an endpoint that's available, so anybody making an IoT device, they'll probably point at multiple rendezvous servers, but we have one that we intend to keep up and keep there, and the performance we're seeing out of what we've done so far is quite excellent. So we're expecting quite good scalability. And then, basically, this is going to take, I kind of view this where FIDO Alliance was maybe 8 years ago. We're getting started. There's a lot of fun stuff coming, but it's going to take a collection of companies. There's a few companies involved with the IoT Working Group now, but they're more the chip guys. They're the Qualcomms, the Intels, ARMs. We need the next layer, application providers, the device makers, and we need to move up the stack to pull these pieces together. So feel free to shoot an email to FDO at loginid.io. If you want to have more conversations, we're looking for partners in this more than customers necessarily. How do we build out this ecosystem, make it secure, make it scalable, and have a lot of fun in doing so? So you can send an email to that, or you can send an email to me personally. And I think we have maybe a couple minutes for questions, David.
Am I on? Yes, we go. Start one question from here. Anyone? There we go.
One of the challenges in this space is, or any space like this is, who's going to be the first large mover, right? I mean, and do you, without going into details, if you can't, do we have anybody who's saying, yeah, we're going to do this? The Siemens, the Honeywell, the Rockwell Automation, et cetera.
So this is an invitation for all those companies to come along, but you have to remember the evolution of the FDO spec. Basically, Intel, Qualcomm, they all see the need for this, and I got to say this right, so it doesn't sound like I'm inviting terrorist attacks, but we're one event away from the federal government going, we got to fix this, okay? So we may all have an aha moment of some sort, and everybody will get serious about this. Otherwise, I think it's incremental. But even incremental is good. There's a lot of places that we need to build out more of the infrastructure. But we are having some interesting conversations with some large companies, and would be happy to talk to large or small companies to get this ecosystem. I think we'll see the innovation from the little guys, and then that'll help the adoption from the big guys.
We got one from online. What about anti-tampering checks in each of the supply chain stages on type of knowing what business entities the device flows through, or checking for tampering as part of onboarding service?
I think that's above my pay grade and perhaps outside the current FDO specification. But it's an interesting question, and please bring your question to join the IoT working group, and I think it would be really interesting to put into that context, unless there's some other industry standards that can help us. Because one of the things that the FIDO Alliance has done really well is say, here's what we're doing, and there's other standards that we bolt up against you. So if there's some other standards in that space, we should probably figure out how they hook up to those. Oh, yeah,
Here,
sure.
Gary.
Oh, yeah, Gary's better.
Yeah, I didn't get it.
Yeah.
Yeah, I didn't get a chance to talk about this, but in some of the talks yesterday, in the context of FIDO and FIDO 2, we talked about the speakers talked about the importance of attestation. That is where a device actually establishes its security state to a relying party. Attestation forms an underpinning of the FDO protocol. I didn't really discuss that in my talk, but I mean, if you go to the spec, you can see that there. So if there has been tampering in the supply chain, presumably the device owner would actually get an indication of it. And actually, the rendezvous service can even get an indication of it too. When I mentioned that the device has to prove it's authentic, part of it is being able to establish its security state. If the rendezvous service can't verify the device's security state, it won't even redirect the device back to the device owner to complete the onboarding process.
And for those of you who weren't here for the earlier talk, that's Gary Mandiam, who's the co-chair of the IoT working group. So he's helped drive a lot of this to where it is.
Second, which is sort of related actually, is the voucher system authoritative? E.g., if a bad actor exists in one step of the supply chain, can they submit malicious vouchers? How is the voucher bound to the device? I think Gary just sort of answered that.
It's bound at the time of manufacture.
Right.
So,
Yeah.
Yeah.
Do we have any other questions here in the room? No. Well then, thank you again, Bill.
Thank you.
Appreciate
And
your time.
Catch me in the hall if you have questions.
Thank you, everybody.